Good evening, everybody. Michael Snyder, Pacific Northwest and California Weather Watch. Today's October 24th, and tonight we're going to do a little bit something different. We're going to do a little educational video here. What are ensembles? I get a lot of questions about this. What does the ensemble mean? What are you talking about when you mention ensemble members? How can this help the forecast? Well, we're going to dive into some of that here and try to make it a little bit easier for everybody to follow along with my daily forecast. So first things first, this is something we look at almost on a daily basis. 500 millibar geopotential height, upper levels of the atmosphere. And I froze this one on this upcoming trough right across Pacific Northwest as we go through October 28th, 12Z. So remember that time there. And I'm going to go ahead and show you the next slide coming up. And you can see, again, probably the portion of the trough that is the strongest here across Seattle-Tacoma International Airport. Again, 12Z there, 28th. And what we have here is all 50 of the European ensemble members. There are 50 of them. So they perturb the initial conditions of all 50 of those members. And then you average them out and you come up with the ensemble mean, which is the green line. If you look closely, you can see that. The blue line is the control run. Those are the initial conditions best we understand them. Each of those 50 ensemble members are perturbed or tweaked to change those initial conditions in our understanding. So then we just let those models run out and they come up with their own plan. They go way off into the future forecast. And when we have good clustering like this, we're pretty confident in the forecast. But as you can see, when you go a little bit further out, you can see this blue box that contains 75th and 25th percentile of those 50 ensemble members starts getting bigger. Our forecast decreases in confidence, and you can see some of these gray lines out there. They start to diverge quite a bit when you look out into the extended forecast. So now looking at this, you can actually see the 50 individual ensemble members. What we're looking at here is Seattle-Tacoma International Airport, 6-hour max wind gusts. So you can look at each one of those individual 50 members. And on the bottom is the control run. Again, the initial conditions, best we understand them. Then we tweak the initial conditions of all these 50 and we just let those suckers run out. Then you can see how it just comes up with some wild solutions. One of them says 50 miles per hour. One of them says 17 miles per hour. And you can look off in the extended and you can see some pretty wild wind readings out there, and of course some much calmer periods. And then if you go to the bottom, the blue bar here is the ensemble mean. That's the average of all 50 of the ensemble members. You can see a little bit of a bump in the wind here for those periods. Now, you can do the same thing for precipitation as well. Take a look here. You can see one of these shows up over 2 inches. It's probably that. Ensemble member number 3 shows 2.1 inches in a 24-hour period. On the flip side, though, you can see some of those individual ensemble members only showing, quarter, 3/10 of an inch, 4/10 of an inch. The blue line, again, is the control run. That's the bottom one here. Those are the initial conditions of the atmosphere, best we understand them. And the green line is the ensemble mean, the average of all 50 ensemble members. And again, the blue boxes here show the 75th and the 25th percentile of each of these individual ensemble members. Hopefully that makes sense. If not, I'm going to keep showing you guys examples and hopefully it starts to click. And we go off into the extended forecast and you can kind of see how the mean and the control start to diverge a little bit, and some of these wild ensemble members showing up there. For example, this one on looks like November 4th shows 1.7 in a 24-hour period. But again, some of its ensemble brothers and sisters out there don't show that much rainfall here. So you can just kind of cherry pick that one, or you can look at the control run and it shows absolutely nothing. So when you're a forecaster and you're looking off into the extended forecast, you don't have much confidence in the forecast out here, no doubt. And just for the sake of it, I did cherry pick ensemble member number 1. Weather.us allows you to see those individual ensemble members. And look at this atmospheric river looking thing pouring into the Pacific Northwest. However, if I go to ensemble member number 2, look at the big differences coming up there. So that's the power of these individual ensemble members, and you just let them run out and they can come up with these wild solutions. And the benefit of this, that is, if you average out, take that ensemble mean, that mean usually outperforms the control run. The best understanding of the initial conditions that we have gets beat by those ensemble members and the ensemble mean when you average them all out. So that is the power of an ensemble forecast. Hopefully that makes sense. Now, taking a look here, you can also do temperatures. And you can see in the short term, pretty good model agreement showing up. You get off into the extended forecast, you can see how things diverge quite a bit. The control run is kind of off in its own, doing its own thing there. And it's even on the outskirts of most of the ensemble members here. And you can see how some of the ensemble members start to diverge and start to disagree quite a bit here as we go out towards election day. And again, the green line is the ensemble mean. The blue boxes are the 75th and the 25th percentile, I believe. Some of these runs or some of these graphics show between the 90th and 10th percent, but that's not really important right now. So we're just going to go ahead and let that ride. I could be wrong with the 75th and the 25th 25th percentile. But anyway, back to what I was talking about here as far as the ensembles. This is what's known as a total precipitation plume. So again, you have all 50 of those ensemble members shown in these gray lines. Then the green line is the mean, the average, which should run right down the middle, and you can see it does. So the control run is in pretty good agreement with the mean coming up here. And again, control, initial conditions, best we understand them, the mean average of all 50 ensemble members. And it is different for the GFS. The GFS has 30 ensemble members. I'll show you that here in a moment. But I did want to show you, for example, Stampede Pass, about 3,000 feet up in the atmosphere. And again, some big disagreement between the individual ensemble members, but the mean and the control make for a pretty confident forecast. You can see they're in lockstep as we go off towards the end of the month here. So we have a pretty confident forecast as far as what is going to happen on these 24-hour segments as far as total precipitation is concerned. Now, looking at Stampede Pass, check it out as far as snowfall is concerned. Some of these individual ensemble members, you could cherry pick some of these. Look at that. What is that? 4.5. You scroll up and you can see 4.6 inches, ensemble member number 43. So you could go shake down number 43 and see exactly what is happening and what's driving all that snow. But you wouldn't make a forecast and just say, hey, we're going to get 4 to 5 inches at Stampede Pass. Obviously, the control and the mean agree about an inch during this 24-hour period. Now, GFS, here we go, Stampede Pass. You can see 30 individual ensemble members here on the left. And again, as you scroll out into the forecast, some of them with big totals, some of them with nothing at all. And you can kind of see that shown as you go off into the future forecast. You can see the control and the mean start to disagree quite a bit. And again, the mean outperforms the control run, especially once you go 3, 4, 5 days out in the forecast. So that is the strength of ensemble forecasting. Now, the GFS, again, 30 ensemble members. This is precipitation amounts, and you can kind of see pretty good agreement on what is coming up as we go through this weekend. Some ensemble members higher, some lower. That makes sense. And then you can see the blue bars here do kind of show some uncertainty on just how much precipitation is going to fall. And you can see the control versus the mean there also. So something else you can do, this is something interesting because here we can look at all of those individual 50 ensemble members on the European. I believe this was the 12Z run from this morning, if I am not mistaken. I believe it is. There it is, yes. And so if I click through these individual ensemble members, look at this as I go through 3. Notice just the subtle tweaking here of the heights at 500 millibars. That's what we do to the atmosphere. So basically we're saying, hey, we might not know exactly what the atmosphere is doing. Let's tweak those initial conditions for all of these 50 ensemble members and let each individual one run out. And as you get off into the future, the chaotic nature of the atmosphere, you can get some really wild divergent solutions when you look at these individual ensemble members. And I'll scroll through here. And of course, in the short term, we have a pretty good idea of what the atmosphere is doing. So you can see a little shimmer, it's doing its little shimmy thing here, 500 millibars, kind of showing you what may be going on here in the short term as far as our understandings and whatnot and these individual ensemble members. So if I scroll all the way out towards Friday, this is November 8th, 4 in the morning. Now let's scroll through some of these. You can imagine you're looking way off into the future here. And if you scroll through here, look at these huge changes. Again, this is the same time frame here, 4 a.m. Friday, November 8th. And you can see how those individual ensemble members just take on a life of their own and make up their own forecasts as you go off into the extended forecast. But the strength of that is when you average all 50 of them and you come up with a mean, then you can kind of detect those troughing patterns and those ridging patterns on through the extended forecast. That is the strength of an ensemble forecast. Now, this is something interesting as well. So we have about 528 500 millibar heights here. So this is very cold in the upper levels of the atmosphere. And if you get towards the equator, of course, the atmosphere is thicker here. So you can see a little bit of ridging here, maybe across some of the west coast. But can anybody guess how many lines you got there? Anybody? Anybody in the back? Hands up. Bueller? 50. That's right. You have 50 of these individual lines. And since we are in the early portion of the forecast, we have a good idea on what the atmosphere is doing. But watch what happens as I start scrolling out into the extended forecast here. bear with me. We're going to go through October 28th now. We're going through the 29th. Does this start to take on a look of something? What do those look like? Do they look like noodles maybe? And if you go far off into the early portion of November, check it out. What does this look like? Looks like a bunch of noodles here, or spaghetti. And that's why they call this a spaghetti plus. You can imagine the gymnastics that a forecaster's mind goes through when a family member comes up and asks you, hey, what do you think the weather's going to be like on election day coming up here? And immediately this is what your mind looks like as a forecaster. You're like, there may be some ridging on the west coast. There's probably going to be some Gulf of Alaska troughing, but you can see these spaghetti lines are all over the place. You've got huge disagreement. And probabilistically speaking, you're going to be like, yeah, I don't really know what's going to happen there. And you'd pretty much be telling the truth. But sometimes these patterns are a bit more clear as you look off into the extended versus other times, but you can still kind of see maybe we'll have some ridging here along the west coast and that Gulf of Alaska trough may be going. Who knows? There's also other ways you can use this ensemble information. So we have probability of precipitation over 0.4 of an inch in a 24-hour period. So basically you're taking those ensemble members and what percentage of them have over 0.4 of an inch during this time frame on Sunday, October 27th, 5 p.m., the last 24 hours. So you can see pretty good agreement there that you're going to be having over 99%, that you're going to have over 0.4 of an inch along the Cascades, the coastal range up into Vancouver Island. And of course, you can scroll through that here as well. So it can give you a probabilistic forecast. And as we move off in towards, Tuesday the 29th over there, you can see we go through a dry period here as well. Now, you can do other crazy things with this also. This is the ensemble, the gust ensemble maximum. This is basically, you can just go through and cherry pick things. It'll show you the highest wind gust of all the 50 ensemble members, and you can just scroll from now all the way through November 8th. So as you can imagine, some extremely wild scenarios show up. You can see some of these gusts over 100 miles per hour over the Olympic Mountains. Of course, it's nothing that you would ever actually, make a forecast with. Obviously, this is just one ensemble member of 50. And, you're way out in fantasy land here. So it's just kind of something you can do with this awesome power here. So that's why sometimes you see things on social media. You've really got to know if you're looking at something that's been totally cherry picked. Can you imagine if I went on Twitter or Bluesky or just on YouTube and I started making a forecast and start showing this, and I showed this ensemble member here and just kind of said, hey, look at this huge windstorm coming on November 8th. There'd be a portion of people that might not know better, and they start to believe that here too. So, it's a pretty big responsibility being a forecaster and dealing with all these tools, no doubt. Now let's wrap it up with this. So this is Quileute Airport on the Washington coastline. This is the 18Z European. So when you're looking at this, this is 6-hour max wind gust, by the way. You can kind of see this pretty quick. You know that it's going to get windy on the Washington coastline here. All 50 ensemble members basically have 50 mile per hour gusts or higher, except just a select few have, I think, 48 and 49. So you're in for a windy period here. You look at the control run, the initial conditions, best we understand them, 55 miles per hour. And some of the individual ensemble members, look at number 16 at 65 miles per hour. Some of these have 60 plus mile per hour gusts here as well. So it's going to get windy here for this time period. The ensemble mean is now the average, like I said, of all these 50 ensemble members. So you can make with high confidence a very good forecast on 50 mile per hour gusts coming to the Washington coast. That's why there are wind advisories up. And this is going to be very late Friday night into Saturday morning. Now, if I cherry pick number 16 there, we can see, and we can back it up a little bit there. You can see pretty tight pressure gradient here with this deep parent low across the Gulf of Alaska, the strong pressure gradient. And we put that into motion, swing up the coastline. And you can kind of see why this is going to affect Vancouver Island, the Washington, Oregon coast a little bit more than interior areas. In fact, the Oregon coast isn't even going to get the brunt of it. It's going to be Washington, Vancouver Island, some of the northwest interior of Washington. But if I scroll through here, now, keep in mind that the individual ensemble members, as we saw, virtually all of them had 50 mile per hour gusts or higher. But I can scroll through here and you can kind of see the changes in the sea level pressure map out over the Pacific Ocean as this strong pressure gradient approaches the Pacific Northwest as we go through Friday night into Saturday morning. So, awesome power, all kinds of stuff you can look at here. The future is exciting as far as artificial intelligence and some of these Ensemble members. The European artificial intelligence has been performing really well, and it's going to eventually get its own Ensemble members also. That is going to be really fun to watch take shape over the next couple of years or so. So yeah, lots of fun stuff to look at. Hopefully this made sense. If not, leave some comments below, because I'm going to do an entire video just on my most basic weather terms and try to make it easier again for everybody to follow along with my daily forecast. That'll be an educational video as well. That should be under the community tab on the channel here. So if you want to go ahead and check that out, leave in the comments below. I've got a whole bunch of replies to that. So I'm just going to go through there when I make the video, and I am going to try to address the most commonly asked questions on when I do my daily briefings. But otherwise, hopefully this makes sense to you. If not, again, don't fret. It's kind of confusing to understand at first, and ask questions, and I'll try to go over it again if people have questions about these ensembles when I do that breakdown as well. So anyway, I'll do my normal briefings tomorrow. Hope you guys are having a good night, and I will talk to you guys later.